Hello, good evening, everyone. So this presentation is about Python, Darknets, and I'm going to share with you research that I did. I will show you proof of concepts that I developed for other systems and what I did in terms of retrieving information automatically about hidden services in Tor. I introduce myself. My name is Danielle, also known as Adastra. I am a trainer and consultant and a researcher of IT security. I've been managing and running the blog thehackerway.com for a few years now, and I always say this because this is part of my lifestyle, the way I see life. I do IT security because I love IT security. Is very much inside me, and I hope that those of you who are here or those of you who are starting also take into account that philosophy, or at least this is my hope. I would like you all to be very much willing to learn and to see IT security beyond a job that will help you makes a living. And well, this is my email address. You can contact me for anything that you may need. I will answer. I will answer not immediately, but as soon as I can, I will answer, because I also have a life outside my job, even though you may think that this is not my case. Alright, so my presentation will be about Python. How many of you are aware of Python or work in Python? Well, nearly everyone in here. Okay, on this front row. So lots of young people here. I guess that you come from a university, you're students, and I guess that you are studying Ruby, Python, and you're also working with Java. Do you also do scripting in Java, isn't it? Okay, no problem. I will also tell you how you can disclose hidden services in the deep way that may have malicious content, that is to say, illegal content, and how we can extract information from these spaces. Well, we should not forget that there is a wide range of information available in Tor or deep web, and this information is not static but rather dynamic. Often we have hidden services today, services that are exposing any type of content which goes against the law, illicit content that it's available today and tomorrow it stops being available, and not because it has been censored, but just because of the content creator has decided to shut down that content, or perhaps that content is only available at specific times during the day or for a specific period of time, and then it is removed from the deep web. And what is this about? First of all, we will talk about anonymous webs that are available in the market. Then what are the anonymity solutions that are available? Probably the ones that you have heard of, Tor and others. Well, there are very many others than Freenet, Descent, Riffle, or Tor. However, these are the ones that are most frequently used for all types of activities, not only for criminal activities, but also for other activities for which these solutions have been created initially. As I say, often Tor is associated with child pornography, selling of arms, and forging of documents, passports. So this is what we most often hear about this Tor and others, but these solutions, Tor, Freenet, Descent, have been thought or are thought so that some of the content in it is not censored, is not forbidden, especially in those countries where there are strong restrictions to access the internet. With this, I'm referring to countries such as China, where there are limitations in terms of accessing some services or expressing some opinions. So in these cases, we have solutions such as Tor, allowing you to go out there, to go outside, and to access that content that otherwise you would not have access in this type of environment. So this is the type of solutions that these solutions have been created for that. We should not overlook, we should not forget that Tor, Freenet, Descent, and others have been created to preserve privacy and anonymity of people. They were not originally created as a platform to commit criminal activities, despite them also being used for criminal activities. So we have others such as Riffle and Rifle is not fully implemented, but it is there, and nowadays Tor Darknet includes more illegal services than the other solutions. So as I said before, Tor is the most widespread, the most popular solution, and therefore the most used for publicizing and publishing some illegal content. Well, we also find malicious content in these solutions. About Tor and all these webs or this darknet has been widely discussed. I'm not going to tell you what Tor is about because I'm sure you are all aware of it. And those of you who are not aware of it, I recommend you listen to Fran and Manu presentations that are sitting here in this room. They also gave that presentation on Tor 2 years ago at CyberCamp. And actually, it's a presentation that you can watch at the INCIBE website. As I say, they delivered that presentation 2 years ago, and I recommend you watch it because they explain very well all the net as well as others. So this is a good way, this is a good introduction for those of you who want to find out more about Tor. Other than Tor, I'm going to talk about Python. So I hope that you have some basic knowledge about Python because I will be mentioning some tools, some libraries that are included in this language. As I say, I expect you to have some basic information and knowledge about it. And I will try this presentation to reach everyone, all the targets here in this room. Services in Tor. What is that? Well, the first thing that we have to do is to find addresses, to be aware of the available services. And the question is, how do you do that on the internet? If you want to find content, what do you do? Well, you make a search, either in Google or you name it. Cheap flights, here, there, you Google that. So you use search engines, and those of you who no, you don't know Start Page? Well, take a look at it. It is quite good. It is a search engine that redirects all your searches to Google. Therefore, You no longer have to give all your data to big Google. Then you go through a start page, which is kind of like a proxy. So the advantage is that you will get the same results that you will get in Google, but this is a different search engine. Get exactly the same results and you are not exposing your privacy. So in solutions such as Tours, we find exactly the same thing. Lots of search engines, lots of indexing pages with onion addresses that help us to find addresses, to find content that may have illegal content in them. We may use fresh onion for that and do searches. ISIS, Daesh, forged passports. So key terms that you could type in any search engine, and then you will get onion addresses as a result. So for instance, if you want to hire a hacker or any illegal content you can think of, you can easily search it through these type of solutions and through the available search engines. Okay, this is already a starting point. We have a number of search engines that we can use to automate our searches, and then we will get a number of onion addresses that are indexed in these search engines. Also, as I said before, the deep web of Tor is dynamic. You will not find the same services all the time. And as I said before, well, you may find a service today, and that service, for whatever reason, may not be available tomorrow, because anyone can publish content in Tor. Actually, it is very, very simple. You only need to add 2 lines to the config file, and that's it. That is enough for you to publish a service in the deep web of Tor with its associated onion address. So if you stop your Tor instance, that would be enough for the service not to be available anymore. Or for instance, to take down the service, whether it is Apache or Gnesh or any other service behind it. Okay, as simple as that. So where to start? So very many sites to use. Darklinks offers very many onion addresses to find the type of services with illegal content. Also Tor links, deep link. Some of these are search engines that we can use right away in Tor. So this is fresh onions. Amia is quite good, quite cool. It's a good search engine. It's often quite updated. Well, fresh onions or Amia. A search engine like any other. You type in your search, Linux. So non-malicious term. And when we browse this type of spaces, we have to get used to lower speed. So this is everything that we get as a result. These are onion addresses that match our search. So what we got as a result, everything that matches Linux, but we could have entered other search term. For instance, I don't know, passport or Daesh or ISIS. Are you getting me? And now we will be having a number of onion addresses to analyze later on. But doing that manually doesn't really make sense because we make hundreds of results and sometimes thousands of results. So it doesn't really make sense to do that manually. You just don't want to go one by one to check whether they are available or not, whether they have the content that you are looking for. You, as I said, you can automate that through scripting, as I will be showing you. This is a very practical presentation. I have some videos here just in case I need them, but because this tool connection is running very well, I will do everything live. So we have, well, we can use very many search engines. So what do we need to interact with this site in a programmatic manner? Well, we only need to know the HTML structure of the website. How do I do my search? Well, okay, let me show you. The search receives the Q parameter. Well, from Python script, what do I have to do? I have to type in the onion address dash search and then the Q parameter, which is the search button, whatever key term, whatever search term that I introduce. I could do that with a programmatic manner with a Python script, and it will only take like 3 lines, okay? 2 lines plus the proxy line. You can do any type of search. Fresh onions. Well, fresh onions also shows you live addresses. So it doesn't show the addresses that are not pointing at anything or have been taken down. So it only shows you active live addresses. It shows you when it has been published, when it was last visited, and the last time where it was published. And then it gives you the address as well as the title or the name of the site. And well, you can do any search, or Daesh or ISIS, you name it. Cyber war. Okay, written in German, in Russian, several onion domains. Some of them are duplicated, but in any way they match the search term. ISIS shows content containing ISIS, and then you see onion addresses. This was published 4 weeks ago and seen a day ago. So very easy to search for this type of to make this type of searches. But then you can also get lots of crap. Okay, what to do now? When you do this type of searches and you come up to the services are data sources. Think about them as databases. So lots of information you can consult. What type of language are we using? We are not using SQL, but we are using HTTP requests. So here we are talking about HTTP hidden services, web servers. But in the deep web of Tor, you can get any type of service as long as they support HTTP protocol. We will be focusing on HTTP, which is the most common web services. Therefore, we want to consult these databases and then to check that the addresses that these databases return are published. For instance, if I type in ISIS for this specific search, then I get a number of onion addresses. Then I have to check that those onion addresses are returning anything to me, that is to say that they are live. So if I check these addresses or consult these addresses and then it tells me that it is down, it is of no use at all. So I'm interested in those services which are live. And well, those that are down, what could I use them for? Well, just for me to know that at a given point in time the address was live and that it is not live anymore. So how do we resolve the issue of solving the problem in the Pythonic way? Have you ever heard about Pythonic libraries or Pythonic code? Only 3 of you? 4 or 5? Okay. So when we talk about solving a problem in the Pythonic way, we mean that Python has been designed so that things are solved easily, only through a few lines of code in the most straightforward manner possible. So when I develop something, when I create something, I like to focus on the problem, but not on the problems that I may get from the actual language. For instance, if you're working on Java, a very cool language, so you may come up with very many problems with the libraries. It is a quite complex language. However, you don't find so many problems in Python. In Python, we focus more on the problem, on solving the problem, and that is the objective. That is to say, solving things in a straightforward manner, so going right away to the problem. And this is what Python allows us to do. How to solve the problem like this? So, we consult databases, number of directories, number of search engines, key terms, any content we may be interested in, and then we make our consultations through HTTP requests. Second, applying patterns to our queries. So, search patterns. For instance, if we look for child porn or ISIS or passports, anything we may be interested in, then we filter those addresses. So we are only interested in those that are live, that are responding to our requests. So we are not interested in those addresses that take us nowhere, and you just don't want to open it and to say, well, it's not found. So we filter those out. Then queries against each of the active addresses and analysis of the response. We will analyze the addresses that we will find in a programmatic manner, and then we will analyze the response. And then what do we mean by response? Getting the HTTP code that the server returns to us and to analyze it. Simple. Well, very, very simple. We just get the return, the text of the response, which is just the ordinary HTTP code. We analyze it, and for instance, we check the labels and links pointing at other unknown addresses, or using Bitcoin addresses, usernames, email addresses, telephone numbers, for instance, for Spain, or with Spanish country code, or for instance, landline numbers or mobile telephone numbers. All that could be done in very easy way. Then, storing the websites that we found, as well as any information that you get. You may store it in a file, in a database. But that information can be stored to analyze it later on offline. We are not going to be log on to the net all the time. We can also do the spidering for each of the services found. You know what a spidering is? Well, more people have raised their hands now. Good. So when we find a page or site, so we want to do scrapping. We just want to see all the links that is pointing us to discover more unknown addresses related to that service. That would be the most interesting thing to do. That is to say, to get more other addresses from that. This is a simple algorithm, and then applying patterns dash expressions to detect illegal content. Any content that we are consulting, any HTTP address that we analyze, we apply a regular expression to it to extract email addresses from that onion address, or as I said before, well, Bitcoin addresses, whatever you can think of, credit cards. These are just patterns, regular expressions that you find in through Stack Overflow or through any other place you can think of on the internet. And last, we isolate the services that match with these patterns. So we have onion addresses with interesting content and feeding with specific patterns. So credit cards or any type of numbers, landlines, mobile numbers, this is what we are looking for. And now each of these steps, how do we do it? Well, we do that through in Python.
Checking database, we need Tor to be up with the proxy socks in order to use it. Then we have request socks or socks spy. These are libraries in Python. It's requests familiar to you, those of you who worked with Python. Requests for 99% of you is a library in order to create HTTP clients. We say import request dot whatever the method you want to use and the address you want to point to. After release 2.10 of request, we can implement different things. Then our Python script imports request to specify the proxy socks that it's up in the local machine, and then we launch the script with request, and we say request.get onion address proxies and the list of proxies, which we do one towards as proxy. And with this, we can check the data source, which are search engines themselves doing HTTP requests through a library. It's very simple. It's 3 lines. Then it gets more complicated. Applying several patterns to queries. We have 8 search engines. Some of them receive patterns, the word we want to search for, on their URL. Others are a web form. They have a box, and the request has to be made afterwards. It's a post request with a specific parameter. Depending on the structure of each search engine, we need to create the routine, the code routine. That would be the second step. And third, filtering addresses we're interested in. We use requests. We have an onion address in the results. We carry out HTTP request. It's like clicking on the link and verifying whether it's up or not.
Espero que se vea bien. Fijaros, este es un script muy sencillo que...
This is a very simple script for the first checks. We use requests. We import the proxy socks specification, a Tor instance that has to be up, in this case, in my machine. So I did it in no time.
Voy a levantarlo así. El puerto 9050 estará abierto.
Port 9050 will be open of proxy socks. All the requests through this port will be routed through Tor. They will go directly to Tor. What do we have here? We have a series of proxies. Wonderful. It's a dictionary in Python. And what do we do next? The simplest thing of them all. We create a function called search under dir. Dir is another search engine that we check. Under dir. It's a different search engines, which are the ones I've explained before, but it's specific. It's malicious because it offers a lot of services which are illegal, per se. Business. Markets, scroll, communications, core sites, hosting, other languages. That's a bit of everything. But its search engine does not filter addresses. You could have everything here, so it's a good source of data for our goal. What do we do with our script? We send the onion address, and when we carry out a search, for example, passports, under there, the HTTP request is made, and take a look at the structure. In this case, search equals passports. This is one of the structure. This is the other one. When to do this without pagination, if we do the term which is included in the search filter, we want pages. We don't want to keep just the result in the first page, 20 pages, 30 pages, depending on how patient we are, because it's going to take time. What do we do now? We use a reserved word here that we will replace later on. We create a cycle of 4. We create a loop that will be repeated for 4 pages, using this criteria to search. So, rubbish. We're going to look for rubbish. We iterate each one of these criteria. We replace criteria wildcard, this text string, with any of these criteria. When concatenated with the address to search, we carry out a request. This is very simple. This would be address to search. This would be the equivalent to this. And lastly, important, we need to specify where are going to go this HTTP request. It's very simple. We're using Python. It's a simple proof of concept. Python 3, POC1. This is going to take a while. But we can see here I'm checking this. And the only thing the script is doing, this first proof of concept, is designing the address I'm looking for and the code of response. Page 1, and child porn, CP, drugs. We're going through the loop. And when it says response to 100, it means the request has been made and the answer is 200. HTTP 200, saying it's okay. Status codes in HTTP. Simple. What we've done with our program is searching those criteria and going through 4 pages with a script in Python, which removing comments and things which are useless. It's just 20 lines, but taking something that would be 15. So that's a basic search engine. Next, proof of concept. Let's get deeper into the problem. First, we keep what we had before, and here we start with our crawling process. It gets a bit complicated, but not too much. So we continue with the same thing. We're using the same search engine, which is under there. And we say, let's search for this criteria, violence-ISIS. We have to say that this was designed for activities developed by law enforcement. You don't usually do this, I think. But you should know it's not too complicated. What do we see here? We are requesting this to this onion address. We replace criteria wildcard by whatever thing you want to look for. And then before doing a request, we invoke this function. We create a queue. And in that queue, it's an LIFO queue. It's a stack, like a stack. Well, in the case, it works the same way. Addresses are getting in, the last in is the first out. Simple. It's a recursive process. It's not yet, but it will be. We have a process in which we go through all the elements of the queue. And what do we do this for each of these iterations? It's an HTTP request for each onion address uncovered. And what do we do with each of these addresses? We try to extract the links. We search with entity or any other search engine you want. We say search for ISIS. It's going to show a series of onion addresses which include ISIS as a criteria. Then we click in each one of them using our program. We carry out our HTTP request against each one of these links for each of the pages we've set. In this case, 4 pages. We obtain responses. What is it of interest for us in these pages? Other links to other pages, so a spidering process or crawling processes. We invoke a function called getLinks, which has nothing, an empty list. The next proof of concept, we use more things. In this particular case, number 2, we do the same thing we did before with crawl. We carry out the crawling process, and then with getLinks, we use a wonderful library called Beautiful Soup. Is it familiar to you? For those of you who put up your hand, you know that with Beautiful Soup, we can analyze the structure of website, whether it's HTML, XML, or any other. Here we have Beautiful Soup, which does this wonderful thing, and with a couple of lines, we can tell it to extract every link in an HTML code and store it in a list. It's wonderful because we have HTML code that we've previously checked and that most likely will include malicious content or illegal content. And out of this page, we're going to extract all the links, all the tags with the attribute href, links in this HTML structure. What are we interested in here? The onion address. We create a database, a series of onion addresses which are directly or indirectly linked to search patterns that we have included. We check that it is a valid address with this function. Is it a valid address? And here we use the validators package that Python has it. And I say, please validate that this address is not taught to web or .onion, because we want everything before the point onion, the .onion, to check that it's a valid address, a minimum length of 16 or 56. Onion addresses have this length. Normal addresses used to have 16. New generation, which was launched last year, can have up to 56. We want to validate it, to check that it's a valid address, not just any silly text that may be included in HTML. And we extract plaintext.onion, so onion addressed. We return that, the onion address, and here below we say we're only interested in single addresses. We create a set, it's a collection in Python that says that every element included in it does not admit a duplicate. It's a list in Python, like a list, but every element included there are unique. You can't have duplicated addresses. They're not going to be duplicated. This is what we return. We're going to have a lot of links. And we will go through them here. Here we get the links, we go through them, they're dynamically included in the queue. We're going to include the links we find, we're going to create a queue with a lot of addresses, and later on we'll process them. So let's execute this process.
Esto puede tardar un buen rato.
This can take a while. Well, this is just a proof of concept. As I said at the beginning, this type of tools, this proof of concepts, are just extraction from other projects in which I've worked with some of my clients. They're not usually executed in this way. They're usually executed in servers with a more solid server infrastructure. It's not enough by just launching the script. You need to put this into Celery, which is a programmed task to be launched once in a while, and it will take the time it needs. It's a process that can take quite a lot of time. This is the process. It's looking for child port page 1, and it's starting to extract all these onion addresses. For example, here, this one is interesting. When it shows this type of failure, it shows that the service was up at some point, but it's not up anymore. It's a typical case in which the service at some point was available, that onion address was registered in under it, but it's not anymore. Host unreachable. The crawling process continues until we stop it. We have something to work with, a lot of onion addresses that will allow us to extract information that may have illegal things in them. I'll launch it again. I prefer some other thing.
Este término fuera, no me gusta. Vamos a...
I don't like this term, I don't like this one, but it is less violent, I guess. Let's see what I can find with this. First one, it says no. It's looking for more. You always have to check that it's up. Here it has found this address. Let's check.
Vamos a ver qué tiene esto. Luego las podemos explorar manualmente.
We can explore them manually later on.
Con mucha paciencia, claro, porque esto a veces lleva su tiempo.
It takes time, so I'm going to change this. It has to connect. Okay, let's see. Some other... This is timed out. It hasn't answered. It hasn't responded in 15 seconds, so that's timeout. Perhaps the network is... the connection is a bit slow. This one, green dots. Let's see. This one. Copy. Let's see.
Bueno, esta es una de las direcciones que hemos encontrado con este procedimiento sencillo.
This is one of the addresses we've found with this simple procedure, and it shows prices in case you want to deal. So we've obtained part of the results. This will be the first part of our job. We have a series of addresses with these topics. We need to analyze the addresses in order to extract the information. And right now we have the fourth part. What do we do? Before we stopped here, just crawling process and including every onion address in a queue. Now we're going to take a step further and we're going to process each URL, each link. How? We just received the link and we apply regular expressions. In this case, we just have a pattern, a regular expression, in order to say what's included in this text. It's an email or a Bitcoin address. And the same, we send an HTTP request against that address. Matches with regular expression given the content we're giving. This contains HTML code of the website we've just found. If there's a coincidence, we print it on our screen. Match, match. And there are no matches, no matches. This is the interesting part of it. Once everything is done, we save to a database or whatever you want. It's usually a database, persistent storing. Now it's looking for ISIS, page 1. It's the same crawling process. It's found an address, which is this one. Now I say, okay, let's see what it is.
Vamos a copiar esto. Vamos a irnos aquí. Y a ver qué tiene eso. Bueno. Aquí habría que analizar qué tiene esto.
Now we should analyze the content of this internally, but it has found an ISIS button in this page, so there should be something here. These are threads, so there should be something related to it. This was timed out. It analyzes connections, and if it finds matches, it says match or no match. It finds patterns for email address or Bitcoin addresses. In this specific case, but we could use regular expressions for credit cards. You have to be creative here. Anything you want to extract. You have to bear in mind that this is just a proof of concept. These are extracts from tools I've created for clients. What platform do you usually create so that this is powerful? You use Flask, Django, based on services and microservices, with a server which is powerful enough so that this type of process is executed in a continuous way in order to get a lot of information. You need a table with lots of onion addresses, which will be the entry points, the search engines for which we're going to carry out our searches. This is what we find in Python. Before continuing, well, the idea of this talk is that, well, I've seen a lot of young people, many of you are students, perhaps, and I would like to show you how powerful Python is as a language and all the things you can do with this type of programming languages. The message is for you to create your own things, to not just launch tools that have already been created. Open your mind, be creative, and create your own tools. It can be in this sense or something else, something that you're passionate about. It will be gratifying and you're going to learn a lot. This is a piece of advice for those of you who are still studying, you're finishing your studies. In my opinion, it's a very good piece of advice and it will help you from a professional point of view. I also advise you to take part in projects, to create your own things, or add something to projects which are already available. Any questions? So either it was crystal clear or you haven't understood anything. Perhaps it's the second one. And details in the presentation, I'll answer as soon as I can. Thank you.